Morning all of you. Today we are discussing progressive wave equation. Progressive wave equation. Progressive wave equation. So this one we are discussing progressive wave equation. See here. How to travel the wave? See here. Sound wave. For example, we are consider sound wave. The disturbance of medium is traveled on the positive x-axis. This is the x-axis and this one is the y-axis. The sound wave is traveled along the positive x-axis. What is meant by wave? The disturbance of medium. The disturbance of medium. So, energy is transferred from one place to another place in a medium. Without medium, the energy is not transferred. Now, two particles, the vibrations of particles we are considered. This is one of the particle, one, and this is the second particle, suppose 2. It is considered like this. So the wave is propagated in a positive x-axis direction. We are deriving the progressive wave equation, and wave is propagated in the positive x-axis direction. Wave means the disturbance of medium. Energy is transferred. Energy is transferred. So how it is transferred? Transferred from one place to another place due to cause of vibrations of the particles. So the particle is vibrated to and fro motion. So again here also the particle is vibrated. So at any instant of time the particle displacement is calculated. Y is equal to A sin omega t. This is the formula. Along the y-axis the particle is vibrated. So y is displacement of particle. Suppose this is the mean position we consider. This is the maximum displacement of particle A. The particle is vibrated, so along the y-axis. Now at any instant of time, depending upon the time, the displacement of particle we are conclude that along the y-axis it is vibrated, particle is vibrated, but energy is transferred along the x-axis. We are deriving the progressive wave equation. Energy transferred means wave is transferred. It is wave, the disturbance of medium which propagates the energy. Energy is transferred like this. Suppose at a time t is equal to 0 seconds. So the particle is here and disturbance, that means energy is exchanges. So energy is exchanges. So the particle is vibrated from here to here in a time of t seconds. The particle is vibrated at a time of t is equal to 0 seconds. Energy is transferred and wave is transferred. The transferred time we are calculating. So totally, so at this place the displacement of wave we are calculating means. So first of all, energy traveled time up from here to here we are calculating. How it is transferred? Due to cause of vibrations of this wave, this particle, due to cause of vibration of this particle. Here one particle is there, here one particle is there. Particle's vibration, energy is transferred. So this particle is vibrated at the time t is equal to 0 seconds, particle is there. But energy is exchanges, energy transferred. So and energy comes to here. Totally how much distance is there from here to here? It is considered x distance. And how much velocity energy is transferred? Remember, energy means wave is transferred. Particles are vibrated here only along the y-axis, but energy is transferred along the x-axis. Due to cause of the vibrations of particles, energy is exchanges in the waveform. Now come to this one. Energy is traveled with a speed is v. That means wave speed is v, and wave distance, traveled distance along the x-axis. Suppose here we are calculating energy equation, that is wave equation. Now energy travel distance is x and energy velocity is e. So therefore the total time. So due to cause of energy, the particle is vibrated from here to here. So particle is gives the energy traveled time x by v, distance by, so velocity is said to be the time, that is the energy traveled time, plus again particle vibrated time is t dash. So total time, so energy traveled from here to here and particle is vibrated. Again particle is comes to its initial position after exchanges total time x by v plus t dash. So therefore t is equal to x by v plus t dash. So t dash is equal to, so that vibrations t dash is equal to, so t minus x by v. So at any instant of time, particle displacement y is equal to a sin omega into, so what is the formula? T minus x by v. This is the particle displacement. In that way, once again I will clarify this one. Particle is vibrated, suppose transfer wave, particle is vibrated perpendicular to the wave propagation. Particle's positions are not changes, but particle is vibrated along with respect to the y-axis. Energy is traveled in the waveform. So this particle is vibrated and transfers the energy. So this particle work is completed. And this energy is comes to here. At that place, one more particle is there. That particle is also vibrated. That particle carries this energy and transferred to the neighbor particle. So what is the displacement of particle? We are calculating the displacement of particle, but at the same time energy is also carries. That particle carries the energy also. So totally the total time taken by this vibration of particle. First of all, why it is vibrated? Energy is coming from the first particle. So that's why it is vibrated. So that's why that vibrated time is nothing but energy traveled time x by v. Then after this particle is vibrated, that vibration time from this mean position to extreme position is t dash. So that is the total time. You can understand? So that is the total time. Means energy is exchanges. Then after this work is completed, this particle work is completed. So suppose it is at initial position, let's consider. So energy is transferred from this particle. So and again energy comes to this particle, nearer to this particle is vibrated. So from here to here it is vibrated. Energy traveled time plus particle vibrated time is nothing but propagation of the wave or the displacement of neighbor particle. So therefore the displacement of neighbor particle is also called as the time taken by the wave from origin to this point. This point is considered P. So finally y is equal to a sin omega t. Omega is nothing but angular velocity. So angular velocity 2 pi by t, so into t minus x by v, where t is time period. So again, so t minus x by v. So y is equal to a sin 2 pi by t. If you take so inside that one t, small t by capital T minus x by t into v. The reciprocal of time period is said to be, so here y is equal to, this is one of the equations simply we can discussing. 1 by t is the frequency, that is L. Now come to this one, again we are using this formula. Now listen. Again we are using this formula. This is also the plane progressive wave equation. Again, if you inside the omega, y is equal to a sine. If you inside that, we are consider omega into t and omega by v into x. If you take the omega inside that one. So what about the omega? Omega is the angular frequency. Now only we are defined at 2 phi by t. That is nothing but 2 phi into n. Already we know that velocity of the wave in lower classes is v is equal to n lambda. Both are substituted here. Y is equal to. So finally y is equal to. See here a sine. So omega t minus omega is nothing but 2 phi into n divided by v is nothing but n lambda into x. So therefore n and n is gets cancelled. Now y is equal to a sine